This conference will now be recorded.
Hey, hi. This is Rajesh Vara. Welcome back again. We are going to discussing about the syntaxes of one-dimensional array. So let us see what is that one-dimensional array and how the array declaration was going to happen, and array initialization was also going to be happen. Okay. The simple syntax for one-dimensional array here is the array declaration, and we can able to see that syntax is the data type, and whatever the data type, there is nothing but int, float, character, whatever it is. Okay, so and it has to follow with this. After this space, it has to follow with the array name, and as well as the size that it has to be specified here now. Okay, so and the size of the array, that what we are calling it as index, is also called as, right. Examples, that simple example that you can able to say, this is what the declaration of an array. Okay, int a of 5. So that means an array name is nothing but a, but it consisting of number of elements is 5 inside then that array list. Okay, fine. Like that float, I'm sorry about, it's not flat, float, float, and the characters and so on, like that we can able to, right. So the array initialization, yeah, this is one of the most important thing actually. The array initialization, how can you read the values into an array? So that is one of the most important thing. Okay, so in order to read the values, or that's what the concept we're calling it as an array initialization, we're able to read the values in two ways. One is at compilation time and another is at runtime. Okay, so there are two ways that we can able to, that means compile time is nothing but, it is nothing but the direct assignment we can able to go for. So but anyway, the concept here is you can able to see that the syntax is data type, array name, and the size that has to be specified, that is equal to list of values that you want to, and immediately it has to close with a semicolon. Right. For example, you can able to see that int a of 4, that is equal to 10, 40, 20, and 50. They are ended with semicolon within the braces, right? So that means the range of array position is 0 to size minus 1. So a of 0th position that was been with an value. What is that? A of 0 is nothing but accessing the elements. How can it? This is 0th position, 1, 2, and 3. So that means the size. So the size is, as the size is 4, 4 minus 1, there is nothing but 3. So the positions are 0, 1, 2, and 3. Okay, so a of 0, we can able to access elements like a of 0. A of 0 means 10. A of 1, which is nothing but 40. A of 2, which is nothing but 20. And a of 3, which is nothing but 50. And something like that, we can able to go and access that. Right? So at the time of initializations, as previously already told that, so it can able to initialization of an array can be happened within two ways. One is at compilation time and another is at runtime, right? The compilation time we already been discussed right now. Just by assigning the direct initialization, you can able to use this kind of direct initializations, right? So that in the compilation time itself, we have few more things, that initializing all the specified memory locations. Array can be initialized at the time of declaration when their initial values are known in advance. If you know the values, then we can able to initialize the values in this way. Okay. And after the during compilation, 5 contiguous memory locations are reserved by the computer for the variable a. So that means, see, a is equal to 5, you say. So that means totally 5 elements are there. 1, 2, 3, 4, 5. Right. This is how the pictorial representation that was going to be shown here now. Okay, so as we have been seen that, so a of 0 is nothing but 10 here now, and the memory location, that was the address location that was being created by your operating system, not by you. Okay, so the not by compiler also. So the memory cell, which is nothing but the 2 bytes of space, as it is an integer data type, then it was going to be occupied with int. So a of 0, a of 1 and 15, a of 2 and 1, a of 3 is 3, and a of 4. That means the range of is 0 to 4, size minus 1. So that means this is how that going to be stored the locations. Okay. So this is 6, 1006 is the memory location, because as it is in 1004, the previous one, that it has to be added with 2 bytes of memory space. That means 1006. Right. So this is how the representation of the array was being created using the initializing all specified memory locations. This is how it was going to be created. Right. Initializing without the size. So without specifying the size, also we can able to initialize the array. So how can you do that? Let us see that. The one of the best example, that so that we can able that what is the size all, regarding the size of size and all, who will take care about it? Your compiler will take care about it. No need to bother about from our side, from the developer side. Okay. So char b is equal to char b of size. Well, I'm not going to specifying any size without size. Okay. That is equal to computer. Computer. That means totally how many values are there? 1, 2, 3, 4, 5, 6, 7, 8. So totally 8 values that was going to be occupied. So what is the size of each value? 1 byte, because as it is a character. Right. In this declaration, even though we have not been specified the exact number of elements to be used in the array B, my array name is B. Right. Then how it was going to be created from starting from 0th location, the size -1, it was go on occupying the each and every value inside into it. Okay. So this is how we are going to be creating those kind of values by initializing the array. Right. So the next one is array initialization. Array initialization with a string. Then how it was going to be occupied. So the char b is equal to computer, so that I'm able to see that how the computer, the string was being occupied into it. So even without specifying the size, but you can able to deal with string also. So in the same way as earlier, each and every character was being stored, but the last character should be occupied with null character /0, because it is a mandatory thing that the logically saying to the compiler that the string was going to be ended. No need to be worried from our side that the compiler itself, it will take care automatically that the null character. Okay. So this is how the representation was being happen using this string. Right. So, but make sure that how many characters, if we am going to using the 9 characters, if I'm going to using the 7 characters, if I specify the size, then it will be a problem. See, I said that, for example, char b of 7. So let us see that one of the best example here is char b of 9, computer. There, yes, because totally 1, 2, 3, 4, 5, 6, 7, and 8, and 9th is also be included because null character is going to be occupied, right? So it is correct only. But what did I said? Char b of 8. I said the next example is it possible? Where is the null character then? So it should not be. So that is what the syntax is wrong. So instead of specifying the size, the better way is to go with without specifying the size, so that your compiler will automatically take care of it. Right? So this is how that has to be taken care of. Right, one of the best example that we can able to the program one-dimensional read and display the values of an array. Okay, so the void main, I had been specified with the size a of 10 and I enter the size of the array. We can able to see that the size has been created, and enter the %d values into the array. That is nothing but the size, whatever the size they are going to be taking in. Right, for I is equal to 0, I is less than the size and I plus. This is what we are calling it as a runtime. But previously, what we had been discussed is nothing but an compile time, because we are going to giving the values directly, but not at the runtime. So this is what the runtime program that we are going to be seeing that. Okay, at runtime we can able to say that the first position I is equal to 0. Yeah, the condition is I is less than size. Size is yes true. That is nothing but 4 now. So size is 4. So 0 is less than 4, true. Right. Then what we have to go? Scanf %d. We are going to entering some kind of values 10, 20, and 30, and 40, and so on. Right. The first value that has to be read into which variable, which location of the array? A of I value is 0. So A of 0. A of 0 has been placed over with 10. And I will increment again. So I will 1. Check the condition. The 1 is less than 4. Yeah, true. Then again, second value. And place it over to which position when A of 1, and so on like this. Keep on reading until the condition becomes false now. Okay. Then finally, in the same way, instead of scanf for reading the things, then we can able to display the values on the screen. So the same logic, but instead of scanf, what we are trying to give him printf. and /t is for the tab space between the values that we are going to be displaying. So a of 0 and a of 1 and a of 2 and a of 3 and so on, the condition becomes false. So this is how we are going to be displaying the values of one-dimensional array, right? So this is on one more. The best examples that we can able to see here is that you can see that, yeah, the linear, the few more examples and the further coming few more examples that we can able to see that using a applications like, you know, searching technique using a single dimensional array. So that means the searching techniques are of two types. One is the linear search and another is the binary search. So both the linear search and as well as the binary search will be implemented using a single dimensional array. Okay, so those techniques we are in the further coming classes we can able to discuss about those things. So this is all about the one-dimensional array. How can you read the values and display the values inside into it? Okay, so this is the program that is the best program that we can able to go for, or you can able to, one of the best example programs that you can able to go for is the linear search and as well as the binary search examples using the single dimensional array. Right. Thank you. Have a good day.